Welcome to the 24th International Conference on Computational and Mathematical Methods in Science and Engineering. This is Oscar Trull speaking on behalf of Ángel Peiro Signes, Juan Carlos García Díaz, and Maribal Segarra Oña. We all belong to Universitat Politécnica de Valencia. This is the Polytechnic University in Valencia, and this is a work made together between the Statistics Department and Management Department. The title of this speech is Prediction of Energy Consumption in Hotels Using Artificial Neural Networks. The contents of this speech, we first will do a brief introduction about the objective of this work, while later we will develop the methodology used in the work. Finally, we will summarize the results and enumerate some conclusions we have written on this work. Let's start with a brief introduction about this work and the main reasons that led us to develop the work shown today. You need to bear in mind, tourism increases 3% yearly. That means the movements, transports, and all related to vacation and travels increases every year about 3%. Since tourism contributes to 5% of global greenhouse emissions, we could state that the global greenhouse emissions will increase just following the graph you can see at the right. If we don't do anything better than improving the current policies, the gas emissions could reach till more than 100 gigatons per year. One of the main contributors to this gas production are the hotels. Hotels consume a lot of energy, and mostly this energy is dedicated to the heating, ventilation, and air condition producing. Hotels are trying to improve all this consumption, just trying to reduce the emissions they produce, not only because of the terms of the cost, but also because sustainability now is one of the key drivers for the tourism. Then, forecasting helps them to have better expectancies and management of the energy they are going to consume, and therefore they are trying to improve these procedures, being more sustainable using these forecasts. So, the main objective of this work is to produce accurate forecast on energy consumption for the hotels. Especially, we have taken a data set of two of the energy consumed by two hotels and some related variables, and we will try to improve the forecast using artificial neural networks. This is the novelty we want to present. We will use artificial neural networks and we will obtain these accurate energy forecasts. In this work, we are going to use machine learning to produce outputs. Machine learning is a field of study that, without being explicitly programmed, allows computers to learn from a given data and produce outputs. In this case, we are going to use artificial neural networks. These networks consist of a series of nodes that are interconnected one with others and allow the transformation and process inputs into different outputs. They can be with some neurons, or there could be even a huge number of neurons. On the left part of this slide, you can see the structure of one neuron. You can see there is a node to which several inputs arrive through a weight. Also, there are some biases arriving to the node, and this node, through a function, this is called the activation function, will process all this information to produce an output. On the right side, you can see the formulae for these nodes and these neurons. At the top, you see how one neuron produces an output with the information given from maybe other neurons or maybe directly from the inputs. The activation function in this case we used is ReLU. This function uses a threshold from which, when the input is greater than this threshold, the activation function will take this value, but if it is under the threshold, then the activation function will give us a value of 0. Neurons are interconnected, just forming a neural network. You can see here in this slide a schema of a neural network. This neural network is divided into 3 main types of layers. The first layer on the left is called the input layer, and it receives information directly from input variables and produces some outputs that are going to use in the next layers. At the right, you can see the output layer, and this layer receives all information coming from the rest of the neurons and produce outputs that are what are we going to look for, these outputs. In the middle, there are hidden layers. There can be 1 layer, 2, 3, or even more. Usually we talk about machine learning when we are talking about some neurons and some layers, but if we use a huge amount of neurons or layers, then we talk about deep machine learning. This neural network must be trained. That means we need to obtain all these weights, and the way to do this is just to use something we call the train set. This is a percentage of the global data set we have. And we start iterating, giving these weights some different values and producing outputs. The outputs are compared with real data, and we measure the error produced from the network. Usually we use the mean square error to compare what the neural network forecasts against the real values. While minimizing this MSE, this mean square error, we will train the network and obtain the best parameters we can for this network. Concerning this work, we have used as inputs the electricity demand from the hotels measured in an hourly interval. Additional to this electricity demand, we obtain some synthetic data in which we measure the recurrence of the electricity demand. A second data set has also been used, and these are the climate data. We have data of the air temperature, pressure, humidity, wind, etc. They have been also already measured, and they match all together. The problem is that with only this information, the neural network doesn't provide results as we expected. Due to that, we introduced some synthetic inputs. These inputs are some other variables that has been obtained from hotel data, and also as a calculation from other variables. For instance, we have the daily occupancy rate. It comes directly from the hotel occupancy, and also the cooling degree day. It measures how the temperature is decreasing from one day to another day compared to one reference. Finally, we have something that has been called room degree day, and the room degree day is just the multiplication of CTD times TORT. We multiply the cooling degree day by the daily occupancy rate. That helps us to improve the results we obtain. As outputs, the objective is to obtain electricity demand, also in hourly intervals. Let's analyze the case we are studying. This is the hourly energy consumption of two hotels located in Cuba during 4 years. As you may see, we can see some features of this graph. For instance, you can see here there is a small trend and comes another trend. This trend seems to be different, and from this point on this trend disappears. This is something that impacts on the results using traditional methods like exponential smoothing or ARIMAS. Due to that, we thought, okay, maybe there could be possibly some machine learning methods that could be applied, and we tried to do it with artificial neural networks. What we did is just to split these two data sets, into one in-sample data and out-of-sample data. The in-sample data is going to be used for training and testing purposes, while the out of this data set of sample is going to be used for validating the forecast provided by the neural networks we are going to use. The first we did was just analyzing some variables we thought that could be related to the consumption. One of the first surprise was that temperature has some relationship, but it is not so big. You can see here the temperature. This is the outside air temperature against the energy consumption in one hotel and in the other. You can see the relationship is similar, and it's not as big as expected. On the other hand, we had that the new synthetic variable RDT has a big relationship with the consumption. Due to that, what we did was just to include it as an input. We were analyzing some other synthetic variables, but the results didn't improve. So finally, in the end, we are using climate data and also these variables. The results obtained by making forecasts using the neural networks can be seen here. On the red dots are the red spots are what is forecasted by the neural network, and here In blue and yellow are the real data for each hotel. This is Hotel 1 and Hotel 2. As you may see, the forecasts are really close to the real demand. And remember, this is out of the sample. These are forecasts made out of the sample. The values obtained were using, in this case for the Hotel 1, 3 hidden layers of 230 neurons on the first, 41 on the second, and 13 on the third, using the same activation function. And while fitting, the root mean of a square error was about 350, and the forecast accuracy measured in mean average percentage error is 2.83%. For the Hotel 2, the hidden layers are smaller. We have only 46, 32, and 49. And the accuracy on the fit is 571. Sorry for this mistake. And the forecast accuracy on measuring mean average percentage error is 2.57%. These two figures are really good because we are talking about some hourly forecasts and measured during 4 months. So that are really good and accurate measurements. Then, finally, we want to enumerate the conclusions we have written on this work. First, hotel electricity demand can be accurately predicted using hotel and climate variables. Remember that the results from this work measured in mean average percentage error is around 2.5%. This is a really accurate value. Second, although this work has been limited only to these 2 hotels, the study could be extrapolated to other hotels using just the same methodology and the same variables. But there is still some research that must be incorporated to this methodology, and this is the occupancy forecast. Because at this moment, this methodology depends on the occupancy rate from the hotel and must be forecasted. Further research will work on this topic just to obtain one single method to produce forecasts on both. References used in this work are presented here. And thank you very much for watching this video, and we expect it has fulfilled all your expectations. Thank you very much.